All right, we're about to dive into one of the most wonderfully bizarre ideas in all of science. It's called quantum entanglement. And this is a concept so strange, it really truly bothered Albert Einstein himself. I mean, it basically challenges the very fabric of reality as we know it. So, yeah, let's get weird.
So our whole story really kicks off with this famous quote from Albert Einstein, "Spooky action at a distance." I mean, think about it. When the guy who literally redefined our entire understanding of space and time, when he calls something spooky, you know it's got to be something really, really out there. So what on earth could be so strange that it actually unnerved Einstein?
Okay, so to really get why Einstein was so concerned, we first have to figure out what even is this spooky action.
Well, this spooky action actually has a proper name. It's called quantum entanglement. And understanding this is the key. It's how we're going to unlock this whole puzzle, because it's a fundamental and honestly a truly baffling part of how our universe works.
And the answer, well, it all comes down to the super bizarre world of subatomic particles. We're talking about a connection between them that seems to defy, well, pretty much all common sense.
So here's how it goes. It all starts with two particles that are created together at the exact same moment. The best way to think about it is like they're two sides of the same coin. They are just intrinsically linked. Whatever happens to one of them is perfectly mirrored in the other. Why? Because on a quantum level, they're basically still part of the same single system.
Okay, but here's where it gets truly mind-bending. This connection, it doesn't care about distance at all. You could separate these two particles by just a few inches or a few miles, or you could literally put them on opposite sides of the galaxy, and that unbreakable link between them, it would still be there.
This link is so weird that scientists, they often say the particles talk to each other. For instance, let's say you measure a property of one particle, like its spin, and you find out its spin up. Well, in that exact same moment, you instantly know for a fact that its entangled partner is spin down. It's like measuring one of them forces the other to immediately snap into the opposite state. And this is the most important part. The communication, this talking that they do, it happens instantly. Not fast, not at the speed of light, not even close. We're talking instantaneously. There is zero travel time for that information.
So yeah, that's quantum entanglement in a nutshell. It's this absolutely bizarre phenomenon where particles are linked and they can influence each other instantly, no matter how far apart they are. It just collapses vast distances into nothing.
And that instantaneous connection, that's what makes this whole thing so revolutionary and, so spooky. It seems to break the most fundamental rules of physics we have, which is, you guessed it, exactly why Einstein was so bothered by it.
Okay, but you might be thinking they're just tiny particles, right? What's the big deal? Well, the big deal, the whole fuss, is because this one strange little behavior seems to violate the ultimate law of the entire cosmos.
And why is that? Because it seems to violate the most fundamental rule of the universe that Einstein himself laid out, the cosmic speed limit. The idea that nothing can travel faster than the speed of light. And yet, this quantum information, this spooky action, it appears to do just that. And that's the conflict right at the very heart of reality.
So, we've looked at the what and the why. But I mean, if countless experiments keep proving that this is real, what does all of this mean for how we understand reality itself?
The answer is, well, it's as simple as it is profound. It means our understanding of physics is broken. It tells us that our normal, everyday, common sense view of the universe, with all its clear rules about space and time and information, that view is fundamentally incomplete. The truth is, reality is much, much stranger than we ever could have imagined.
And really, that just leaves us with one final thought to chew on. If a rule as sacred as the cosmic speed limit can be bent or even broken by this spooky action, it really has to make you wonder, right? What other rules of our reality are just waiting for us to discover that they aren't really rules at all?